Okay, hey everybody. Thank you for joining us this evening and welcome to integrating coding into your existing curriculum to boost student achievement. I'm going to be your host this evening. I'm Jeff Epps. I'm the CEO of Stimrel City. We are a supplemental learning company located here in North Carolina. And our goal is to work with students and parents and educational leaders, community leaders, to show them how to integrate science, technology, engineering, and mathematics into student learning to boost their achievement in the classroom and prepare them to compete in the global workplace. All right, so I'm not going to waste a whole lot of time this evening. We're going to get you started because, hey, it's 6 p.m., it's on a Tuesday. I know you've had a trying day at your job, so I'm going to give you what you need so that you can get a well-deserved break in your schedule. Okay, so let's get started. The objective for today is to demonstrate how coding can be implemented into core classes to boost student achievement. And so what is computer programming, or what we call coding? Well, computer programming is defined as the process of creating computer software using programming languages. And it's much like the same way we speak different languages such as French or Spanish. Computers can understand programs written in certain languages, and these are called programming languages. Because before you leave this session tonight, I want you to understand the direct connection between reading, writing, and coding. It's all the same skill set, okay? That's why students who actually do well in foreign language classes, taking foreign languages, would probably make great coders because they're very well versed at deciphering foreign syntax or decoding foreign syntax and coding it into another language. And that's what coding is, okay? It's the same exact skill set. Okay, so before we can move forward, we have to define computational thinking. And computational thinking is a set of problem-solving methods, okay, problem-solving methods that involve expressing problems and their solutions in ways that a computer could execute. And that's exactly what we're going to do this evening. We are going to solve problems, and we're going to create solutions, and we're going to do it so that a computer can execute it. That's what coding is. So that's why computational thinking, it's important to define that term at this point, because computational thinking and writing code are really the same thing. So why should we integrate coding into core subject areas? Well, basically because it strengthens the analysis, logical thinking, inferencing, and sequencing skills of each participant. When students read, they're coding and decoding. When students are coding on a computer, they're reading and they're actually writing. And as a result of that, their analysis skills, their logical thinking skills, inferencing and sequencing skills are all strengthened, okay, because they're actually practicing it. And I will say this, if you go back and try what we're going to do today in your class, I guarantee you, you're going to have some students that will probably just mentally shut down because they're not used to thinking from a computational perspective. But that's why it's important that we integrate this into core subjects so that students get used to doing this, because it is a skill, okay? Computational thinking is a skill. All right, so this is what I believe. I don't believe teachers should have to teach coding, okay? Core subject teachers should not have to teach coding in order to teach their students, all right? I don't believe that. I truly believe that we can teach teachers to utilize coding to teach. All right, let me say that one more time, because some of you may be saying, okay, what did he just say? I don't believe, I'm not here to teach teachers how to teach coding, because that sort of infers that there is a curriculum behind that. And I don't think any of you out there want another curriculum, right? So I don't believe we should teach teachers how to teach coding in their core classrooms. We want to teach them how to utilize coding to teach and visualize learning objectives to make them more tangible for their students. And that's what you're going to see today. So this slide talks about the essential tasks that teachers need to be able to perform. And it says to implement coding into core subject areas, teachers must know how to perform the following tasks. Commenting, because commenting is a way to make sure that your text is properly written out, okay, that it's properly explained. So when someone looks at your block of code, they can kind of tell what the lines what the lines of code actually do. So commenting is very important. Then we're going to we'll talk about declaring variables. Teachers need to know how to declare variables, because variables store information, whether it's text or numbers. And then there's declaring mathematical functions. Now, one of the things about STEM that I believe a lot of people get confused sometimes is that when we talk about STEM, we're talking about teaching math. Well, not necessarily. Well, when we're talking about the M in STEM, which is mathematics, we're talking about finding math in a particular course subject area, in a subject area. There's math in the science classroom. There's math in the social studies classroom. There's math, of course, in the math classroom. But when we can find math in different core areas, then we're truly, utilizing the M, or the math in STEM. And for teachers to effectively utilize coding in the classroom, well, we have to be able to create mathematical functions to compute the results that we want. And you'll see that in our examples here in just a few minutes. And then there is evaluate the results, okay? we when you're writing code, you've got to have some way of evaluating the results to see if it's true or false, or if it's greater than, less than, equal to, those types of things, because that brings in the logical thinking part of coding, which of course logical thinking, if then, those types of components of reading and writing are also in coding. Then we need a way to print the results to the screen, okay? Send the results out so that we can look at it, right? So, I mean, basically I've got what, 1, 2, 3, 4, 5 different tasks for teachers to know how to perform. And these are not that difficult, ladies and gentlemen, and you'll see that in our examples coming up. But in most cases, okay, in most cases, for you to convert an existing lesson into a coding lesson, you won't need any more than about 10 lines of code, really, honestly. Some of you are probably saying, really, Jeff? I'm telling you, really, and I'm going to show you that. All right, so now that we've discussed all of that, now let's get to the nitty gritty, right? How to convert a learning objective into a coding activity. All right, so these are demonstrations that we're going to use. So I'm going to start by bringing up the program we're going to be using. And this particular program is called Microsoft Small Basic. Okay, it's a free program, it's a Microsoft program, and it's very effective. And one of the things that I like about it is it allows you to transition students from block-based coding into actual text-based coding, where they're actually writing sentences that a computer understands. And you'll see that in just a moment. And it's really one of the only programs that does that, but I like it because it's free and it works on multiple platforms. It will run on a Chromebook and it will run on a Windows device, okay? So, and I'm all about using the free stuff. Why buy something if you can get something free that's just as effective? So the website is smallbasic.com, just like it sounds, smallbasic.com, and it brings you up to this site with the little, looks like the little turtle people on it. And you can even download Small Basic onto a Windows computer and run it, or you can just start coding in the browser. Now, Microsoft just implemented the browser function not too long ago, and I was happy to see that, because before it would only run on a Windows device. So I applaud Microsoft for creating a web-based version, because this really changes the game. All right, so we're going to click on Start Coding Online, and for this particular session, don't try to follow me on this, okay? I mean, if you can, fine, but don't try to follow me. Just visualize this right now. I'm recording this webinar so you can go back and play it later, all right? So when you start Small Basic, it starts out with a block of code here, and I'm going to blow this up just to make sure that you can see it. Okay, there we go. And notice here on line 1, it says a new program, and it's kind of highlighted in green, and there's an apostrophe there. Well, that's the commenting that I was talking about, okay? It allows you to sort of illustrate, or from a text-based perspective, tell the user what each line does. So any line that's preceded by an apostrophe, the computer just ignores it, and it assumes that you're writing a comment. So that's a good thing to have. And then this block of code here, or this line of code, line number 2, it says text window dot write line, what is your name? And then line 3, name equals text window dot read. And notice I'm reading this literally, ladies and gentlemen. Okay, I'm not speaking in some type of tongue. I'm reading it as you're seeing it. Line 4 being text window dot write line hello plus name exclamation point, right? All right, so take a few seconds and just look at this block of code and tell me what you think it does. Okay, I'm gonna give you 30 seconds. Go. Okay, so if we break it down line by line, okay, it looks like the computer is going to ask us for our name. And then in line 3, well, how about this? Let's run it. Let's run it right quick. And it says, when we run it, it says, what is your name? So I'm going to type in Jeff and press enter. And it says, hello, Jeff. Okay. And with the exclamation point, and then it says program is ended. Okay, so now I'm going to go back to the block of code. So now that you've seen what the block of code does, it's now easier to understand why it's written this way. Okay, so line 2 basically says text window write line, what is your name? And that's why we saw that. Okay, we saw that in the block of code. Hey, Tanya Little, thank you for joining us. Let me see here. I hope you can hear me okay. Okay, if you can't hear me, just feel free to go ahead and chat me in and let me know whether or not you can hear me. Okay, I'm gonna go ahead and continue. So we're looking at this block of code, and we can see that it's asking, what is your name? And then line 3, what it does is it takes what we type in, right? Because text window dot read says, read what's typed into the text window. Okay, excellent, Tanya, thanks. Um, so, and then it takes what we type in, and it assigns it to a variable called name. Remember, I said that one of the things that teachers have to know how to do is how to declare variables and assign values to those variables. And then in line 4, what it does is it simply prints hello, and then it attaches the value of name in line 3 and puts it here. So if we run it again, it says, what is your name? My name is Jeff. Hello, Jeff. Okay. Now, here's the interesting thing, ladies and gentlemen. To teach coding, as I said before, you don't have to teach teachers how to teach coding. we're going to teach teachers how to utilize coding to visualize learning objectives. So with this simple block of code with a group of students, would I actually have them type this block of code in? Depending on the amount of time I had, yes, maybe. Okay, but I can tell you from experience, um, you know, uh, keyboarding is something that needs to be brought back into schools. We might assume that kids know how to keyboard, but I'm here to tell you, in my experience, when we do coding sessions, we spend the first 30 minutes helping students find out where specific keys are on the keyboard. So, and Tanya, you're an administrator. I'll say this as well. You know, that's not something that I completely recommend when a teacher is using coding to visualize a learning objective, okay? Because time is very precious in the classroom, especially if you only have an hour and a half or so of instruction. So you don't want to waste that time with students trying to type in code and you spend 35 to 45 minutes just getting the code typed in, okay? In most cases, the code can be pre-written and the students can simply load it and start manipulating it and getting the results that you want out of the block of instruction. So, for example, with this block of code, no, I would not have students actually type it in. I'd have them bring it up, I'd have them run it, but then I would ask them interesting questions and have them make modifications to the code. So, for example, it says, "What is your name?" What if I change that to "Enter your name," right? So now I'm editing this block of code, and I might ask the students now, how do I, um, instead of it saying hello to Jeff, that's it, flip the classroom. And so the next thing we would do is, for example, if I wanted it to say, good morning, Jeff, right? Or good morning to the user, I'd have them change it here. Okay. And so now when I run it, enter your name, Jeff, good morning, Jeff. Okay, so what we've essentially done is we've had the student go through the code, analyze it, right? Analysis, that's a writing skill. Well, we're doing the same thing here with code. We're strengthening those skills, analyzing the block of code, okay? And we're making changes to the block of code to reflect the results that we're looking for. That's the scientific method. So now we're putting the S in STEM in this particular lesson. So that's one of the things I would make the note for everyone attending the session. When you have when your teachers are using code to visualize objectives, you know, one of the things you don't want to do is waste a whole lot of time keying in the blocks of code, because if you have a CTE class or a class that actually teaches coding, that can happen in that classroom, and this is how the two can actually complement each other. All right, so we've worked with this block of code. Now let's convert an actual lesson, okay? All right, so I am going to block out or delete this block of code. So I've got a blank slate here, and I've got this WordPad document that I've got open. And we're going to start with math. And this is a 6th grade math common core learning objectives, and it's ratios and proportions. And I promise you, this is right off the Common Core website, okay? So, and it says the ratio of wings to beaks in the birdhouse at the zoo was 2-to-1, because for every 2 wings, there was 1 beak. And this is how the questions are going to come at students on the end of grade assessments. And so that's why we want to get them used to that in the classroom, especially when we're integrating code. So you'll notice that in this particular document, I have several words that are highlighted in yellow, okay? Notice that these words are nouns, okay? These are nouns, and your nouns will become variables in your block of code, okay? So that's a little tip or a little trick that you can work with your students on. When you give them a word problem, have them identify the nouns. And once they identify the nouns, that becomes a list of potential variables that will be used in our block of code. All right, so what I'm going to do now is I've got the block of code written for time's sake, for the sake of time, but I'm going to go ahead and paste that into my window. Okay, so this is the block of code for that learning objective. Okay, and I'm going to do this real quick so that you can compare the two. Okay, we said the ratio of wings to beaks in the birdhouse at the zoo was 2-to-1 because for every 2 wings, there was 1 beak. So we identified wings, beaks, birdhouse, and zoo, okay, as our nouns in this particular word problem. Well, now the key becomes which of the nouns or do we use as variables? Well, in the in our block of code, we pulled the number of birds. So I created a variable called the number of birds. Then I created a variable called the number of beaks, and then a variable for the number of wings. Okay, so I pulled those directly from the actual word problem. So now, as I said before, in order for teachers to learn how to code, they have to know how to comment, right? So I might come up here and I'll put a comment in, okay? And I'll say that, let's see. I'll call this variable for the number of birds in the I'll say variable for the number of birds. How about that? Okay. Now for line number 3, I'm going to say that this is the variable for the number of beaks. Okay. And then finally, variable. And the reason you want to, you know, I always train teachers to actually comment their code because it makes it visual for their students. Okay, it makes it easier for your students to actually for the students to break down the code and understand why it's coded that way. I've got a little typo there. There we go. Variable for the number of wings. Okay, so now I've commented all of this, and so we've established variables for each one, and we've given each variable a value. Okay, so I said there are 2 birds in the birdhouse. Well, if there are 2 birds in the birdhouse, and for every bird there's only 1 beak, so I'm going to multiply the number of birds. I'm going to say that the number of beaks is equal to the number of birds times 1, right? And then of course with the number of wings, for every bird there are 2 wings in the birdhouse. So what I'm going to do is multiply the number of the number of wings is going to be equal to the number of birds times 2. So let's run it. And what we see is that if there are 2 birds in the birdhouse, then there are 2 beaks and 4 wings in the birdhouse. So we've just visualized that Common Core objective using code. And the great thing is, as I said before in the beginning, we've got less than 10 lines of code here. and Tanya and other participants, you know, for teachers, you don't want them to spend a whole lot of time writing code or trying to figure out how to write code, because they're not there to teach code. They're there to teach with code. So this could be a great bell ringer. When students walk in the classroom, this is sitting up there on the board or on the projector, and without a computer now, this is unplugged. This is an unplugged assignment. Students could analyze this block of code and tell you what it does, sort of as a warm up to the activity that morning in the classroom before they ever run it. Then they can take their Chromebooks out. Then they can actually load the block of code and then run it and better understand how it works. So now that we've coded our solution, right? We can now ask more. Absolutely. Yes, Tanya. So now the next step is, now that we've got the code, and students understand where the magic is happening, right? The magic is happening here, the magic is happening here, the magic is happening here. Now we can teach, okay? So I can say, well, what if there were 30 birds in the birdhouse? And of course, the students are gonna say, oh, that's gonna be 60 beaks. Okay, show me. Okay, now you can say, show me with code. Show me that that's the answer. So students will have to analyze, change the number of birds, right, to 30, and then run it. So now we have 30. So we could then give them a list of questions. What if there were 30 birds? What if there were 100 birds? You know, show me the block of code that does that. All right, so now what if we said, okay, so we now want to give them a similar problem to solve, okay? Because once they get this and they understand the relationship between this block of code, right? This block of code they have and this word problem, now we give them practice by giving them a similar problem to solve, right? All right, so let's do that. Let's say I create, oh, I'm gonna give myself some space down here. All right, so let's say I give them a new problem now. And let's say the ratio of trunks number of trunks to, let's see. Now I may be wrong here, folks. I was never that good at some subjects. I believe elephants have hoofs. I think, is that right, Tanya? Do they have hoofs? Let's see. And then in the and I'm going to say here, elephant cage. Is hooves, trunks to hooves is 1 to 4, right? Yeah, I know, right? Is 1 to 4, because for every one trunk, right? Every one trunk, there are 4 hoofs. Okay, so now what we've basically done is we've given them another word problem, but it's now similar. And you'll hear me whenever I'm working with students, right? Whenever I'm working with students, I always issue challenges. I'll give them a block of code, and then I'll say, okay, now here's your challenge, because now we want to challenge them to think. Well, what students can do now is they can do a little compare and contrast. And once again, comparing and contrasting, that's a reading skill, okay? That's a reading and writing skill. I've written tons of compare and contrast papers in college, enough to know. And so now what students will do is they can look at that problem and say, okay, I need to change number of birds, and I need to say elephants. Okay, and everywhere where I have, I'm going to change that to elephants. Okay, so now what we're doing is we're challenging students to think. We're putting those. Um, okay, good. That's a good one. I'll leave it at hooves for this example, but Tanya just corrected me. uh, Elephants. Okay, so I've got my number of elephants, and then I need to change um, hoofs, right? Hoofs, and I need to change the number of, no, I'm sorry, trunks. Trunks, that should be trunks. Okay, and then number of hoofs. Okay, and then I need number of elephants down here. Then I need number of trunks. And as you can see, I mean, you really have to be thinking while you're doing this, because you have to be watching the code. You have to make the proper changes. So I've got to change this here, and I've got to change this here. And then I have to change this here. And okay, so we've changed our block of code, and I said, okay, what if there were 5 elephants in the room? Okay, so now we also have to change the number of hooves, because for every 1 trunk there are 4 hooves, right? So looks like we've made our changes, and when we run it, okay, now the block of code reflects the actual word problem. Okay, and so now we can ask more interesting questions. We can ask, what if there were 20 elephants, right? Okay, so this makes it tangible for students, and it makes it visual, because in your classrooms are tons of students, lots of students who are very visual with their learning. And for some of them, if they can't interact with it or they can't see it, it really doesn't exist to them. And so that's what coding really does, is it makes it visual, but it also makes it interactive for them. So the teacher could then give them um, you know other word problems based on this, which gets them in the mode of taking a word problem and converting it into a coding exercise. Okay, so for a teacher, this isn't a lot of lines of code. Teachers should learn how to write basic lines of code, but they shouldn't have to teach coding to use it in their classroom. They should know how to write simple blocks of code, find the math, and perform the math functions, and then simply post that code for their students to use, and have them update and manipulate the code, of course, to get the exact results. And when students run it and they don't get the results, they have to go back and modify it. Then they run it, they don't get the results, they go back and modify it. That's the scientific method. Okay, that's the S in STEM. All right, so let's take a look at another example. And I'm going to pull up, let's see here. Ooh, how about a science standard? This is a 7th grade science. Okay. This particular objective is 7th grade, and it's understanding the forms of energy, energy transfer, and transformation, and conservation in mechanical systems. So it starts out with kinetic energy. Okay, so what we're going to do now is we're going to use code to visualize kinetic energy, or to convert to convert mass and velocity into joules for kinetic energy. So, and it even says here, and I've got it highlighted, kinetic energy is, all right, the word is, that's equals, right? We learned that in math. When you see the word is in a word problem, that generally means equals. So kinetic energy equals, right, there it is directly proportional to the mass, which is the m of the object, and the square of its velocity. And it gives us a specific formula right there. Okay, so we can use this information to actually code. And I have the block of code here. Let me copy and paste it. And let's get rid of this guy and put this in. All right, so if we look at what we have in terms of our word problem and in terms of our block of code, what I really love about coding, yes, absolutely, absolutely, Tanya. What we're noticing here is that we have our variables. I've created a variable called mass, okay, from the keywords, from the noun here. I've got velocity, and then I've got kinetic energy. But what I really love about coding is it allows you to simplify math. Okay, and I broke it down as far as you could go. It's 1/2 times the mass times the velocity, which could easily be the velocity squared. But for a lot of students, they can't comprehend that 2 squared is 2 times 2. But when you write it out as 2 times 2, all of a sudden it clicks for them. So I broke it down in its simplest form. So now we have our formula to calculate kinetic energy in joules, right? So I have several word problems here. It says calculate the kinetic energy in joules possessed by each of the following objects. Remember to use the correct number of significant figures in your answer. So we've got a 500-gram wooden block moving at 2 what was it? What was that? Uh, 2 meters per second. Okay. Um, so, um, so for A, what we're going to do is, I know that 500 grams, we've got to convert that to kilograms. So I know that 500 grams is equal to 0.5 kilograms. The velocity is 2, right? And so we're going to now calculate the kinetic energy in joules. And guess what? When we run it, we get 1 joule. Okay. So if we go back and we look at the same exact formula, but now we have a different question. It's 71 kilograms and 1 meter per second. So we go, here we go, was that 71? 71 and 1, 71 and 1. Okay, see how much easier it makes it when you're able to visualize it, and now all students have to do is interact with it and view the results. Okay, and it's 35 and a half. And then if we look at 71 kilograms and 5, okay, 5 meters a second. All right, there's our answer. And then finally, let's see, 1816. Oops. Okay. And 26.8. Okay. and we have our answer. Okay, so once again, now understanding kinetic energy, or the kinetic energy, we now know how to do that, and we were able to do that in just 4 lines of code. It doesn't take a whole lot of code to visualize something like this. You know, it just takes the time to put the code together. And one of the things that I do at Stemrel City is we work with teachers on building these simple blocks of code, because once the block of code is created, hey, you can use it over and over again, and then you can get more creative with it and build the the actual word problems that are associated with it, to get your students into that mindset, so that when they take these end of course tests or end of grade tests, that they are able to read a word problem, and maybe even using scratch paper, write a simple block of code to actually get the right answer. So this is simply visualizing it for them. All right, one last block of code here. Now I'm gonna let me go ahead and preface this next block of code. It's going to look massive, okay? However, it did not take long to write, because there was a lot of copying and pasting involved. So the question could be, all right, so we have implemented coding into math. We've implemented coding into science, integrated coding into science. How would you convert an ELA? Okay, an ELA learning objective into code? Well, good question. So let me delete this, and I'm going to bring up this block of code here. Okay, I don't want you to be intimidated by this, because there's really not a lot to it. So a while back, I was approached by an ELA teacher. All right, now as you can see here, there are 135 lines of code, but a lot of this was copy and paste, and let me explain why. An ELA teacher approached me and said, okay, Jeff, I heard you say that you could implement coding into my ELA classroom. I don't see how you could do it, but I'm all ears. So I said, all right, what are you studying right now? And she said, well, we're studying The Veldt by Ray Bradbury. And I've always loved Ray Bradbury growing up as a kid. And The Veldt, I actually read the story because it was about this futuristic room that they had in this house. I had her send me the lesson plan, and I noticed right off the bat that the lesson plan was broken down into sections. In ELA, there is this thing called the exposition, right? I have it in here. Then there is the rising action. I've got that here. Okay, and then I've got the rising action part 2. Then I have rising action part 3 right here, okay? And then I had rising action part 4. So, okay, so we're breaking it all down. And then she had something called the for real rising action. So we got that. And then finally we had the climax, okay? And then there's the falling action. So these are all parts of a story, right? So using code, there's a way for you to jump from one part of the story to the other in coding. Or in coding, there's a way for you to jump from one block to another block of code. Okay, so that's what I did with when she broke down the different parts of a story. I just turned them into what we called subroutines, or a place where you could jump from one place to the other. Now let me run it so you can see how it looks. So first thing it asks is, what is your name? So my name is Jeff. And it says, hello, Jeff. Welcome to the Veldt. And it says, type go and press enter when you are ready to continue. So what I essentially did was I converted the reading passage into a text-based video game for students. I mean, those of you, now I'm showing my age. I'm 51 years old. I played text-based video games like The Legend of Zelda and stuff like that. So I've always been fascinated with text-based video games. So I thought, wouldn't that be a cool way to introduce students to a reading passage by converting it into a video game that they would have to read, and actually they could control what happens. So it says here, type go and press enter. So I'm going to type the word go, but notice the word go is in all uppercase. If I type in G-O, lowercase, it takes me back to the same place. So now I have to do some reading, and I have to be very focused on what I was doing. Now, in that particular classroom, this ELA teacher was blown away because it was complete silence when the kids were going through this as a text-based video game. And she said, that's the first time I've ever had this much silence in the classroom. So, all right, so I'm going to type in go, G-O, capital G-O, and it takes me to the next passage, right? And it talks about the Velt, and then it tells me what to type to go to the next session. And it says type go to nursery. So I type go to nursery. And it continues to take me throughout the entire game or the entire passage as a video game, okay? And in this particular passage, George and Linda have to run because these holographic lions are coming at them. So you're actually giving them commands on specifically what to do. Now, let's go back real quick and let's break down the block of code. And I think it's gonna make me go through all of it. Run, George, and Linda, or Lydia. And notice there are 3 exclamation parts. And then let's see, change scene to Aladdin. Okay. And then call David McLean. So these were commands that we built into the text-based video game so that students felt like they were in control of what was going on, but it also forced them to read. They couldn't just next, 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 or press enter, pass everything. Okay, turn off nursery. So as you can see, it was hard for students to actually get out of the game without reading it. Okay, run downstairs. Where are your parents? This is where their children. Okay, and then it says, thanks. It says, thanks, Jeff. I hope you enjoyed it. Goodbye. Program is ended. Okay. Now, if we go back to the block of code, now check this out. This is where all the magic is happening. Remember how we told it to, we were able to tell it the foreground, all of the, well, in the foreground, all of the tasks that students had to perform were green. Well, that's why. Right here, we changed the color to green. Notice how it asks me for my name, and then it floats my name throughout the program. Here's where it tells them to type go, but here's the cool thing. Remember I said that when teachers are writing code, they have to have a way to evaluate input, to tell it whether it's true or false or so on. So here is where when it tells you to type in go, in line number 10, it checks to see if you typed it in correctly. Okay, and if it's G-O, capital G-O, then it says go to exposition. It jumps down to here, right? But if the answer is not equal to G-O, then it goes back to start. And that's why it takes you in a loop when you do not type the right thing. So the lesson was for students to go through the game, so they went through it. Then we had them make changes to the games. We said, okay, now instead of all of the text that instructs you what to do to be green, change it to a different color. Change the text that Notice how all the text that came out for you to read was actually white. We had them change that. Then we actually had them change some of the commands, okay? And so students got a great understanding of how this text-based video game was written, and then they knew how to go in and make the proper changes. So now another challenge for students would be to take a writing passage and convert it into a small text-based video game. That's a great project. I challenge some students to do it um, at a middle school, and you just wouldn't have believed what they came back with. And the two ELA teachers in this middle school, they were so excited about this project. It was unbelievable. But this is how you could do this in the ELA classroom. You could do this in the social studies classroom, okay? Because social studies, right, it's all about history and it's all about outcomes, okay? And, you know, you could have students maybe rewrite the outcome based on certain criteria, but they would have to code that. So we have about 8 minutes left. And so this is basically how you can actually convert learning objectives into coding lessons. But now, this requires teachers to receive some type of professional development training. But I will say this, they do not need to learn how to teach coding. They need to learn how to utilize code to visualize a specific learning objectives. And that's a skill that they can learn, but it's not something, in my opinion, that they're going to learn in a 2-hour session or a 3-hour session. They have to get exposed to coding as a whole, and then have that sustained training moving forward to work with them on converting existing lessons so that they get to a point that they could do that as well. So let me go back to the PowerPoint here. Um, so I'll open this up really quick for Q&A. Are there any questions? You can put those into the chat window. I'll be glad to answer those. And while we're doing that, I'm going to go ahead and put my contact information up here as well. This is my phone number. That's my website. You feel free to reach out to me anytime. You know, I believe in the sustained STEM, the sustained STEM professional development model. I believe in, you know, you got to expose teachers up front, but then there has to be that work with them in the classroom where you come in and you can model it for them the first time so that they could see how it connects to their learning objectives and the impact that it's going to have on their classrooms. And yeah, absolutely, Tanya, it's definitely not one and done. But then after that, you know, you work with them on modeling it themselves, and that's how we move the needle of student achievement. Coding has to be integrated into student learning. It's great that we have coding classes in CTE classrooms, and I think that's great. But if we're going to move the needle in terms of student achievement, though, okay, it has to be implemented into core classes, and it has to be a sustained professional development model. So I hope this has been helpful to everyone. And feel free to reach out to me anytime. I'll be posting this video again online on my website, and I'll send you a link to it just in case you want to review it. But we will be doing some other sessions as well. I intend to do another session on how to use 3D modeling, okay, which is basically mechanical engineering. How do you use that to visualize learning objectives in the classroom? I mean, that's going to be really fun because I love playing with shapes and stuff like that. But that's another way that we can visualize learning objectives for students and really move the needle on student achievement. So if there are no more questions, thank you for joining. We'll be doing more of these, and feel free to leave me any comments or email me with any comments or questions that you might have. This is Jeff Epps. I hope you've enjoyed it because I've had fun, and we'll be doing more of this in the future. Thank you. Take care, everybody.